Hello everyone, I am Kedung Fletcher from Politeknik Kuching, Sarawak. Today, I would like to present about pH monitoring for liquid fertilizer management in black pepper farming. In these presentations, I will cover 5 main topics, which are introductions, literature review, system design, result and discussions, and the last one will be the summary. As you know, Sarawak is the main producer of pepper in Malaysia. Pepper is produced and planted by rural dwellers which are concentrated in certain districts of Kuching, Samarahan, Sri Aman, Betong and Sarike division in Sarawak. The crop is very important to Sarawak as the crop supporting the livelihood of about 33,000 rural farmers. However, the current practice for pepper productions, from land clearing, stem nursery, pest management to harvesting, is maintained and monitored via traditional method. Fertilizer is the costliest farm inputs for pepper farmers to boost the farm yield. So therefore, the applications of precision agriculture using IoT could be the mitigation step forward to reduce the farm input, especially the usage of unnecessary fertilizer for the pepper vines need. The agriculture sector in Sarawak will experience drastic changes over the next 5 years with the application of smart farming. However, the black pepper farmers still employ the traditional practice of farming from site preparations to harvesting. With escalating costs of farm inputs such as fertilizer, pesticide and labor, it is very hard for pepper farmers to sustain their farm. Furthermore, pepper requires large volumes of nutrients to maintain significant growth and yield. Hence, there is a need to explore some other alternative with it cost-effective and able to monitor the usage of farm input in systematic manner. Thus, this paper is to propose the usage of IoT in black pepper farming to transform traditional practices to smart farming. The objectives of this paper are to manage the usage of fertilizer in pepper farming, to develop apps based using Raspberry Pi, and to record the information of fertilizer usage in pepper farming. Numerous researches have been conducted in agriculture domain to improve yield productions and at the same time reducing the agriculture input such as the fertilizer and the use of natural resources such as water. So these are the 5 studies conducted in order to identify the best system requirements and the parameters needed in developing this monitoring system. Next, I would like to present on the system design. The figure represents the architecture of the system. There are 6 modules involved in the system design. The first module is Microcontroller, which is the Raspberry Pi. The second one is pH sensor. The third one is Fertilizer Farm. The fourth one is GSM module. The fifth one is the web database. And the last one is the Fertilizer Management Apps. Microcontroller, which is the Raspberry Pi, is the central processing unit. It performs the main role of the entire system. It is responsible for controlling the pH sensor to get the soil acidic or alkaline status in real-time mode. So in here, we are using the Python integrated development to enable us to develop programs in communicating pH sensor, fertilizer pump controller, GSM module, fertilizer management apps, and web database. The data from the sensor is then sent to the web database for storing and monitoring by the farmers. pH sensor module. So for this system, we are using DF robot gravity analog pH sensor. It is used to measure the soil pH. The pH is a number between 0 to 14, where neutral condition is 7, acidic condition is lower than 7, meanwhile alkaline is more than 7. For black pepper vines to grow healthily, the pH should be between 5.5 to 6.5. The pH sensor collected data from pepper environment and sent data to Raspberry Pi module. The Raspberry Pi module sent data via GSM module to website database. The figure here shows how pH data is displayed on web and applications. The third module is Fertilizer Farm. The conventional fertilization methods from site preparations to harvesting system usually result in wasting lots of fertilizer. The high or low amount of water or fertilization can damage the pepper vine's roots, leading to unhealthy crops. So based on pH data presented on the web database, the user will be able to make sound decision either to switch on the pump using fertilizer management apps from their mobile device. The next module is the GSM module. As our system needs to communicate with sensor, fertilizer pump, web database, and fertilizer management apps. GSM module, also called GSM modem, is mandatory. We subscribe with Cellcom provider for our SIM card for data transmission from Raspberry Pi and pH sensor to the web database and to switch on and off the fertilizer pump from fertilizer management apps. To communicate with all the devices in our system, the Python program is developed. The next module is web database. The system employs MySQL as relational database to store pH data from sensors and fertilizer pump management. The data can be viewed via website www.agrofarming.info. The figure shows the web interface and the mobile interface. The last module is fertilizer management apps. This figure represents the process flow in fertilizer management apps, where this application is controlled by Raspberry Pi to switch the fertilizer pump. So data of fertilizations and watering of the farm will be recorded in the database. The system will send the data such as status of the pump, time and day. Then the output will be shown from the Agrofarming info website. Farmer can track record when the fertilizer was used. Next, I'm going to discuss on the result and discussions. So this figure represents the fertilizer management apps. These apps help farmers with efficient, reliable, and well-informed for their pepper vine status. The apps is developed using Android platform. Data from sensors, which are pH data and water and fertilizer informations, are sent via wireless to the web-based database, which is MySQL. Hostinger is used as a web server and PHP as the tool to develop the interface between IoT system, database, and users or farmers. In these applications, once the pump on, the system will record the durations of pump operation time. This is important to provide optimum watering and fertilization of pepper vines. Too much water and fertilizer will cause fungal or disease infections to the pepper vines. This figure represents the pump duration operation time. Farmer may schedule the watering and fertilizations of the pump when they are sure about the condition of the farm environment. This can be done when farmers have local weather data that can determine whether a farm should be watered or fertilized. The apps also provides manual switch on and off the water and fertilizer pump when the farmers notice that pH readings are below 5.5 or more than 6.5. Table below shows the recommendation action to the farmer based on the pH readings. pH status will make it easier for the farmers to make sound decisions on pepper farming activities, such as predicting the amount of water and fertilizer required. The adaptations of precision agriculture through IoT implementations enables a sustainable agriculture that allow farmers to maximize yields and reduce the natural resources. Ladies and gentlemen, I think that's the end of my presentation today. Thank you for your attention.